We humans have become pretty good at sending things to space, but once a spacecraft is up there, moving it around can be trickier, especially if it's tiny. The fiery rocket launches we know and love involve engines that are just too powerful for something like a toaster-sized CubeSat once it's in space. These little probes and satellites sometimes just need gentle nudges instead of big shoves. But unlike traditional rocket engines, these spacecraft do need engines that can keep nudging for years or decades without running out of fuel. And one promising new way of accomplishing that is called Electrospray Propulsion. It nudges spacecraft with tiny charged droplets, and it's already quietly passed rigorous tests on one of the most sensitive probes we've got. All rocketry is based on our old friend Isaac Newton's third law of motion, which says that forces always come in pairs. One way or another, fuel gets pushed out of the back of the rocket, and when the rocket pushes back on the fuel also pushes forward on the rocket. So the spacecraft moves. That's true whether the rocket uses explosions or squeezes air out of a balloon. Huge traditional rockets, the kind that get things off the Earth, are a lot closer to the explosion side and use energetic chemical reactions. But these engines can deliver more power than a lot of tiny probes need, and they can go through their fuel faster than we'd like for long-term, low-maintenance missions. This is where electrospray propulsion comes in. It's a type of ion engine, which uses strong electric fields to push electrically charged atoms, called ions, out of the back of the ship. These engines can be tiny and efficient. Like thrusters the size of quarters can work continuously for weeks at a time. They can do this by providing way smaller forces than chemical engines and go through their fuel a lot more slowly. And that's perfect for something like a CubeSat, a lightweight mini satellite that needs to gather data from orbit for a long time. There are actually a few types of ion engines already, and one was even used for the Dawn mission to the asteroid belt. But these engines are a little different than electrospray ones. Traditionally, ion engines work by relying on a bunch of individual atoms for thrust. The atoms are pushed out the back and the craft moves forward. But electrospray engines use tiny charged droplets of liquid or groups of atoms for thrust instead. Those liquids might be something like molten salts, although engineers are still trying to find the best materials for the job. Some thrusters might even use mixtures of liquids, which scientists sometimes call a colloid, so they're also sometimes known as colloid thrusters. One major benefit of these engines over other kinds of ion propulsion is that they're a lot easier to control and fine-tune. If you only need a little force for your spacecraft, it's a lot easier to create a smaller droplet of liquid than it is to control a bunch of individual atoms. This kind of control is perfect for some of today's smallest satellites, like CubeSats or the even tinier nanosatellites, which usually don't have any propulsion systems of their own. Usually they just stay in space until the atmosphere drags them back down. But as methods like electrospray become cheaper, easier, and more widespread, we'll start seeing CubeSats that can stay in space almost indefinitely. And the good news is, research into these engines has recently picked up, because as people have started imagining the kinds of things we could do with a lot of small, inexpensive Earth-orbiting satellites, electrospray propulsion has seemed even more important. Like with a bunch of satellites like this, you could have internet access or phone signals everywhere on Earth. Governments would also have an easier time monitoring things like nuclear arms treaties, and scientists would have an easier time tracking something like climate change. And of course, fleets of small, exquisitely sensitive satellites and probes would help astronomers too. We might not even have to wait very long before this technology is ready to go. The European Space Agency's LISA Pathfinder probe tested electrospray engines between 2015 and 2017. LISA was a proof of concept for a planned team of probes that will hopefully search for gravitational waves, ripples in space caused by super dense objects moving around. Gravitational waves are unimaginably tiny, so probes looking for them will have to be super sensitive to have any shot at success. LISA's engines and other stabilizers had to be able to move or turn the ship by the width of a single strand of DNA, and then stop without jolting. And they needed to keep that precision up for hours or even days at a time. And with 8 electrospray engines on board, LISA achieved all of its ridiculously precise goals. Now, electrospray engines won't suddenly become the only engines out there. We'll still need bigger engines to get satellites off of Earth and to push around larger spacecraft. But as they're improved and refined over the next decade or two, we'll probably see them on a lot more of the Earth-orbiting satellites and space-based observatories that make our lives easier. So hopefully we'll have a lot more to say about them soon. Thanks for watching this episode of SciShow Space. If you'd like to learn about another kind of experimental engine, one that could get humans to Mars in just over a month, you can watch our episode all about the Vasmer engine.